Hi, this lesson is going to be very simple. There's only two concepts that I'm going to be talking about during this lesson. And those two concepts are, the first one is we're going to talk about the difference between mass and weight and why we talk about mass in chemistry. And then the second one is conversion, temperature conversions. So the very first thing that I want to talk about is mass. So you've probably heard the definition for matter before, right? Matter is anything that has mass and takes up space, right? Okay, so you are made of mass, right? I am made of mass. Okay, so mass deals with the material present. Now this is really important that you pay attention to this, right? So if I asked you the question, do you have any mass on the moon? I hope your answer is yes. Why? Because if you're on the moon, you're still made up of stuff, right? And that stuff just happens to be atoms, which we'll eventually talk about. So mass is how much stuff is present inside of a material. Okay, so anytime that we're talking about how much stuff is present, we'll be talking about mass. So if I tell you to mass something, I'm asking you to tell me how much stuff is there, right? Most of the time that's measured in grams. Okay. Weight is a different concept that you deal with more readily in physics, okay? But what weight is, it's just the force that measures the pull on a given mass by gravity, okay? So weight is actually going to be the thing that changes as you go from like here to the moon, right? Your weight will change, it'll actually drop, it'll be less when you're on the moon because you don't have as much Earth gravity pulling on you. Okay, and just a little tidbit here, the gravity that we're talking about is that 8 meters per second squared, right? Okay, but you don't have to worry about that because the most thing that I'll talk about here is mass. So just make sure that you know the difference between mass and weight. So weight, here's our equation here, is the mass times the acceleration due to gravity, which I wrote right there, which is just mg. You won't have to calculate that, but just know what it is. That's the first thing. Second thing is conversions within temperature. Okay, now I know that the target says I can convert between Celsius, Kelvin, and Fahrenheit, but we don't do anything with Fahrenheit in here. Our thermometers are Celsius, so we are just worried about the conversion between Celsius and Kelvin. Okay, so let's talk about what temperature means first of all. Temperature just measures how hot or cold something is, okay? And the conversion that we use most readily is this K, which is Kelvin, is equal to degrees Celsius plus 273. Okay, now let's talk about this for a second. I know that you've heard about absolute zero, right? Does anybody know what absolute zero is? Or what it means? Absolute zero is 0 Kelvin, okay? And at absolute zero, this is when particles no longer move, okay? We've never achieved absolute zero. We've gotten really, really close in the lab, but we're not actually there. The temperature that's actually out in space is like around 3 Kelvin. But 0 Kelvin is when all of the particles inside of your body or all the particles inside of an object completely have no more movement, okay? Hasn't been achieved yet. Okay, so let's talk about why we need this conversion, okay? The Kelvin scale is based off of absolute zero, okay, and a lot of stuff that we deal with in chemistry. However, Kelvin is not actually a measurable temperature, meaning I don't have a thermometer that measures Kelvin, okay? But I do have a thermometer that measures degrees Celsius, okay? So we need a conversion between something that I can measure to something that actually makes more sense to my content in chemistry, okay? So that conversion is going to be Kelvin is going to be equal to the degrees Celsius plus 273, which is easy. Conversion's super easy, okay? So in this case, if I have something that is 0 Kelvin, what is that going to be in degrees Celsius, okay? If I wanted to rearrange this equation for degrees Celsius, what would I have to do? Well, I would have to subtract 273 from both sides, right? So then degrees Celsius would be equal to Kelvin minus 273, okay? So 0 Kelvin, which is absolute zero, no particles moving, is actually negative 273 degrees Celsius. So we've never been there yet, okay? Where on the other hand, you have seen 0 degrees Celsius before, right? That's when you get snow days, when the water freezes and snow and ice covers the road. You have seen 0 degrees Celsius before, which is just going to be equal to this 0 plus 273, which would be 273 Kelvin. Now you'll notice that there's no degree sign on Kelvin because, again, it's a measurable thing. We can't measure it with a thermometer, therefore we have to measure with degrees Celsius and then convert it to Kelvin. So let's look. Which one of these guys is absolute zero? The answer to that question is going to be 0 Kelvin. Why? Because we can't achieve it. We can achieve 0 degrees Celsius, and luckily when we hit 0 degrees Celsius, not our particles have stopped movement, which means we can still be alive. Okay? So that's the end of this lecture. Hope you learned something. Thanks.